Have you ever gazed up at the night sky and wondered what lights out there? Beyond the skies, our planet, our galaxy. Or were you ever fascinated with the rocket launches and new discoveries on the news? On the other end of the spectrum, many would disagree and find space exploration an utter waste of money. For instance, in the last year alone, NASA spent over 18 million on space exploration and research, and although it's only 0.5% of the total US federal budget of $3 trillion, that's still a lot of money. Which brings us to the question, why are we exploring space? Is space exploration really worth the investment? How will space exploration impact us? And how much of the universe can we actually explore? With the rapid development of space technology, space exploration has been made easier. Just look at what Elon Musk, the CEO of SpaceX, did. He sent a small payload into space that consisted of an old cherry red Tesla sports car with a spacesuited mannequin strapped to the driver's seat and the radio set playing the David Bowie soundtrack on a loop. In fact, early this year, SpaceX launched the SpaceX Falcon Heavy. The rocket is designed to be reusable and transport a payload of around 5 large elephants in space. It also has a performance double the world's next powerful rocket, but at 1/3 of the costs. With such modern-day technology, there was a lot of potential for us to reach space and explore the universe further beyond what we know. Furthermore, there are even more possibilities for space travel technology that we know of and have laid down theoretical framework for, but haven't gotten around to realizing. These include nuclear pulse propulsion, where nuclear reactions are used to directly propel the craft via the massive force generated, and solar sails, where the radiation pressure of sunlight drives a large mirror-like structure. Other ideas include Bussard ramjets, ion thrusting, nuclear thermal rockets, and MPD thrusters. Any of these may see use in expeditions to star systems far away, being generally more efficient and enduring than chemical rockets. As our scientific knowledge expands more, we may see more exciting and feasible ways to advance into the so-called final frontier. Space exploration is not just about discovering new stars and planets through telescopes. It also involves us sending probes and astronauts to explore celestial objects at close distances. The main reason why we invest in space exploration is because of the economic benefits it brings us. Through the exploration of space research, our vision and understanding of the universe expands, giving us more information to develop space technology to benefit us on Earth. It is because of this, since NASA's establishment in 1958, that many U.S. presidents have had a major play in the U.S. civilian space effort, with each president's emphasis on space exploration as their overriding goal for NASA. Space technology has also been recognized for its strategic importance and possible role in military affairs. This was demonstrated in space-based missile defense systems designed during the Cold War, and more recently by President Trump's declaration of a space force. However, there are still many unpredictable and unknown risks in space. Popular sci-fi films such as Arrival, Gravity, and Interstellar have no problem portraying these tragedies and accidents. For example, the Space Shuttle Columbia exploded during re-entry in 2003, killing 7 astronauts on board and costing a whopping $13 billion. Space radiation is a constant threat to astronauts, as humans only have limited toleration of radiation. Galactic cosmic rays can damage DNA in human cells, cause mutations, and stimulate cancer, and in extreme cases, an acute dose of radiation can cause sickness, burns, and organ failure. In space, to protect astronauts against radiation shields are often added to the spacecraft, but this adds extra mass, meaning less room for a scientific payload and astronaut facilities. In addition, when high-energy galactic rays hit a spacecraft, shielding may produce a shower of energetic particles and radiation in the form of X and gamma rays, offering no protection for the astronauts during extravehicular activity, such as spacewalks. Other similar phenomena, such as solar emissions, may also harm space explorers. Debris in space is also a concern. Small and big objects float around in space and may easily come in the path of spacecraft. Since spacecraft will travel at high speeds, the relative velocity of these objects to the spacecraft upon collision would also be high, and even the smallest rock may damage a poorly built shuttle heavily. With our understanding of the universe today, how much of the universe can we actually explore? Are there any limits as to how far we can go? Currently, only 93 billion light-years of the universe is observable to us. However, the entire entity of the universe still remains unknown. How much of the observable universe can we reach with our probes and spaceships? Well, to be honest, not much of it. For one, it takes a really long time to travel in space. What if we were to explore outside our solar system or venture out of our galaxy? If we traveled at 17.3 kilometers per second, it would take us 40 billion years to get to the nearest galaxy that is like our own, the Andromeda Galaxy. Despite such odds, humanity has always had an interest in pushing beyond our limits. Perhaps someday we might travel beyond our world. With all that being said, what do you think of space exploration? Should we explore space? And where do you think space exploration will take us to by 2030?